We've already covered several uses for this great percent formula here, A equals R times B. Same formula can also be used to answer percent increase and decrease problems. A still stands for after, and B still stands for before, like we've talked about here. But when you do percent increase or decrease, you're now answering the question, how far is my answer from 100%? Because if you're still at 100% of what you were, your answer hasn't changed. So, let's look at an example right here. We want to go from 24 to 29. Well, I started at 24, so that's going to be my before here in the problem. And I'm going to 29, so afterwards, I'm at 29, and I don't know my rate right here. I want to figure out what that is. To solve this for x, I divide both sides by 24. And when you do that, you're going to get 120, or it's 1.208, and then it's 3 repeating. So it's about 1.208 for your answer. Remembering, of course, that this has to be written as a percent, since this is our rates. This is the same thing as 120.8%. Now, if I just said what percent of 24 is 29, the problem would be over. But I asked for the percent increase or decrease. If something doesn't change, it's still at 100%. Our answer here is 120.8%. That means it increased by 20.8%. So we could say this is our percentage here, or we could say it's a 20.8% increase. They mean the same thing, but it's just a matter of answering the question that they wanted. They wanted the increase, there it is. On our second problem, we're going from 40 to 7. Before we were at 40, afterwards we ended up at 7, don't know the rates. And when we divide both sides by 40 right here, we are going to end up with 0.175. So as a percentage, of course, that's 17.5%, but that's only the straight percentage here. We don't care about that. We want to know what the increase or decrease is. Again, if we don't change, we're at 100%, but we're down to 17.5%. That is an 82.5% decrease. Do the same problem as normal. It's just that when you get your answer, you have to look at how far you are from 100%.